Hello, we're going to talk about our M&M chi-squared activity. And when you're finished, it should be turned into Schoology by the end of today. So hopefully you went out and collected some M&Ms. If not, here is my collection of M&Ms. So this came out of a normal size bag of plain M&Ms. All right, and so I had 14. I counted out and recorded 14 orange, 13 yellow, 11 red, 5 blue, 8 green, and 4 brown. This information is going to go on, let me switch. If we log into our Schoology, and Monday, we have our chi-squared activity. Here's the link to the notes you should have looked at over the weekend. So here in our assignment, we have our data sheet and a statistics handout and the bag of M&Ms, or you can use mine from before. We look at our data sheet. So here's some data from second period, and here's my data. I totaled this up. We had the entire class to look at. And now we're going to have to analyze all that data that we collected using chi-squared analysis. Chi-square analysis will help us to determine if the claim made by Mars Company of these percentages is correct. So Mars states that in a bag of M&Ms, there should be 13% brown, 24% blue, 20% orange, 16% green, 13% red, and 14% yellow. And so we're going to see if that is in fact true. Our null hypothesis. A null hypothesis states that any variation in an experiment is due to chance and not to whatever effect was given in like an experiment. In the case of this experiment, we can record our null hypothesis is that there will be no difference between our percentages of M&Ms and the percentages given from the Mars Company. So data table 2, you would need to record your numbers and your percentages. We'll come back to table 3. Table 4 is where we're going to calculate the class data together. So the observed, we come here. I actually have table 4. It's completed down here. And here we go. Somebody must have added something later. The numbers aren't matching. They match here. This is the third period's data. Here we have, for the class totals, the observed percentages of M&Ms. And so that's what we'll write down on your table 4 in the observed column. Expected, these match the percentages given by the Mars Company. Then we calculated the difference. So I had to subtract the observed and the expected. So I did 12.82 minus 13 gave me negative 0.18. And I did that for blue, orange, green, red, and yellow. Again, taking the observed 17.59 minus 14 gives me 3.59. Then I have the difference squared. So I took this negative 18, squared it, gives me 0.0324. Again, did that for all of my values. Then I have to take this difference squared, so the 0.0324, and I divided that by my expected. So if we look up here at the formula chart, I have B44, which is this number here, divided by the expected, divided by 13. Gives me 0.0025. And I repeat it for all of my different categories. And now here I can see then my chi-squared value is 3.0899. I got that number by adding up everything in the fifth row. Gives me this, 3.089. So what does this number mean? First, we have to figure out our degrees of freedom. For that, you need the AP Biology formula sheet. Degrees of freedom, right here. Degrees of freedom are equal to the number of distinct possible outcomes minus 1. So if we come back and look at our M&Ms, we have 1, 2, 3, 4, 5, 6 possible outcomes. So our degrees of freedom is 5, because 6 minus 1 is 5. Then it says, based on the class data, should you fail to reject or reject the null hypothesis, and why? So our data was 3.0089. If we come back and look at our chi-squared table now, degrees of freedom is 5. We always in biology use the p-value of 0.05. And so where they intersect, our critical value is 11.07. That is our critical value. And so we can write that our chi-squared is less than our critical value. Anytime chi-square is less than critical value, then we are going to fail to reject, which is another way of saying accept. That says that our null hypothesis, based on the data we have, is correct, that there is no difference. And we got some good statistical numbers and data. And even though, if we come back and look at our table, even though like with blue, we got 17%, it said it should have been 24, but as a whole, no difference from the expected, from what Mars told us it should be. Only difference is due to chance. All right, on your own now, you get to practice this. You're going to go through and use just your observations, your smaller sample size. Chance has a bigger impact on, and so you'll probably get different chi-squared, which means you might end up rejecting the null based off of your smaller sample. But you'll complete table 3, answer questions 1, 2, and then 4 and 5, and turn this assignment in. All right, always email, let me know if you have any questions for me.